The unveiling of the mighty Hornet 4 marks a significant development in the evolving landscape of unmanned aerial combat systems. The collaboration between the US-based Kratos Defense and Security Solutions and Taiwan's National Chung-Shan Institute of Science and Technology, NCSIST, reflects a pragmatic approach to modernizing military capabilities while leveraging proven technology. At the recent Taipei Aerospace and Defense Technology Exhibition, the partners showcased the conversion of the MQM-178 Firejet, a widely used subsonic aerial target drone, into a high-speed attack unmanned aerial vehicle, UAV. This initiative demonstrates how existing platforms can be reimagined for offensive operations, potentially reshaping tactical options for nations seeking rapid and cost-effective solutions in the high-tech battlefield environment. The mighty Hornet 4 is designed to reach speeds approaching Mach 0.8, operate at altitudes above 35,000 feet, and perform missions within advanced manned-unmanned teaming (MUMT) frameworks. The choice to repurpose the MQM-178 airframe is noteworthy because it balances affordability, reliability, and aerodynamic predictability. By building on an existing and well-understood platform, the developers have avoided the prolonged development cycles typically associated with entirely new UAV programs. Instead, they focused on integrating attack payloads, enhanced sensors, and communication systems capable of supporting sophisticated joint operations with manned aircraft. The approach reflects a growing trend in military technology, optimizing known systems to deliver new capabilities faster and with reduced risk. Kratos brings decades of experience in unmanned systems to the partnership, particularly in the design and marketing of tactical UAVs, while NCSIST handles the technical adaptation and integration for local defense needs. This division of labor highlights an increasingly common model in defense collaboration, wherein foreign expertise complements domestic industrial capability. Such arrangements not only accelerate development but also enhance technological sovereignty, a critical consideration for Taiwan amid regional security tensions. The collaboration signals a strategic intent to expand operational options and increase resilience by combining proven designs with localized innovation. From a technical perspective, the conversion of the Firejet into the mighty Hornet 4 involved extensive modifications to propulsion, structural elements, and onboard mission systems. Engineers reworked the internal architecture to accommodate weapon systems while maintaining speed and maneuverability under high G loads. Trials cited by the developers indicate the aircraft can sustain operational altitudes of more than 10,600 meters while maintaining Mach 0.8 speeds, enabling a combination of rapid transit and deliberate loitering phases for target acquisition. Such flexibility mirrors the operational concepts employed by loitering munitions, which blend fast penetration with precision strike capability. These traits make the mighty Hornet 4 suitable for roles including rapid strike, close air support, and coordinated missions with crewed aircraft, rather than long-duration surveillance or persistent intelligence gathering. The integration of manned-unmanned teaming capabilities is central to the platform's conceptual value. The mighty Hornet 4 is presented as a versatile force multiplier, capable of relaying sensor data, acting as a decoy, and executing coordinated attacks alongside manned aircraft. Achieving practical interoperability in such scenarios requires resilient communication links, standardized protocols, and a sensor suite designed for real-time data exchange. Operational validation will be critical to ensure these systems function reliably under combat conditions, a process that involves not only technical testing but also simulated and live training exercises to confirm mission effectiveness. The commercial dimension of the project is equally significant. By converting an existing airframe rather than designing a UAV from scratch, Kratos and NCSIST offer a solution that reduces development costs and shortens time to deployment. This approach appeals to potential international customers seeking advanced capabilities without the expense and delay of new platform development. However, the initiative also raises complex questions related to export control, regulatory compliance, and the governance of dual-use systems. Balancing commercial interests with security concerns remains a persistent challenge, particularly in the context of high-speed attack drones capable of precision strikes. Politically, the unveiling of the mighty Hornet 4 carries symbolic as well as practical weight. For Taiwan, demonstrating advanced UAV capabilities enhances defense credibility and signals ongoing investment in domestic aerospace development. The program underscores the value of local adaptation and industrial participation in augmenting national security, a factor of heightened importance given the island's strategic position in a contested region. For the United States, the collaboration represents a model of constructive defense engagement that prioritizes technology transfer, local capacity building, and operational effectiveness while reinforcing bilateral security ties. The Taipei exhibition served not only as a technology showcase but also as a strategic signal to regional observers and potential international buyers, illustrating the convergence of defense innovation and diplomatic signaling in contemporary military procurement. The decision to employ the MQM-178 as a foundation for the mighty Hornet 4 highlights a broader shift in defense strategy, where affordability, adaptability, and rapid fielding increasingly drive procurement choices. High-speed UAVs capable of integrated operations with manned aircraft are becoming essential tools for modern air forces, offering advantages in precision, survivability, and operational flexibility. Platforms like the mighty Hornet 4 allow militaries to experiment with new tactics and operational concepts without committing to entirely untested airframes, thus mitigating risk while expanding capability. Moreover, the adaptability of such systems ensures that they can evolve alongside emerging threats and technological developments, preserving relevance over time. The operational implications extend beyond the battlefield. By demonstrating the ability to convert a familiar target drone into a sophisticated attack UAV, Kratos and Xist highlight the potential for dual-use platforms to reshape force posture. Such programs encourage strategic agility, enabling militaries to field advanced systems quickly in response to changing threats. At the same time, they illustrate the growing role of unmanned systems in modern warfare, where speed, precision, and integration with manned assets increasingly define the outcome of engagements. The mighty Hornet 4, therefore, represents both a technological achievement and a conceptual experiment in how UAVs can complement traditional air power. Looking ahead, the success of the mighty Hornet 4 will depend on rigorous operational testing, refinement of MUMT protocols, and the ability to sustain high performance under realistic combat conditions. Its adoption by regional forces could accelerate interest in similar conversions of existing UAV platforms, potentially influencing procurement strategies across multiple countries. By balancing cost efficiency with advanced capability, the program exemplifies a pragmatic approach to modern defense challenges, one that leverages existing assets to create flexible and potent solutions for contemporary operational needs. In conclusion, the mighty Hornet 4 embodies a convergence of innovation, strategy, and practicality. Its development illustrates the potential of repurposing established platforms to meet emerging threats, the importance of collaborative defense partnerships, and the strategic benefits of integrating unmanned systems with traditional military assets. By converting a widely recognized target drone into a high-speed attack UAV capable of MUMT operations, Kratos and Xist have not only demonstrated technical ingenuity but also provided a model for future defense modernization initiatives. The platform's emergence highlights the evolving nature of aerial combat, the strategic value of UAVs, and the complex interplay between technology, geopolitics, and industrial capability in shaping modern military power.